Hello and welcome to my new course all about research methods. We're going to be focusing mostly on social science and criminal justice because that's really my particular field, of course. But this course can be taken by, really anybody interested in research and how science is performed and so on and so forth. So, science and the process of creating science is incredibly important, right? I mean, I'm recording this on a computer with a webcam and sending it out over the internet, I'm sure via some kind of satellite and fiber optic cable and hitting servers around the world, all because this process of science and research built up over centuries to bring us to this point. Science and research are really at the core of modern life, right? We couldn't have civilization as we know it unless, early humans somewhere in an African savanna did enough research to figure out that cooked food is better than raw food, right? Which, obviously they weren't using the strict scientific process at the time, but that is, kind of the antecedent to everything that we have today, from the internet that you're using to watch this video to our cell phones and medicine and, all the other lovely trappings of modern life that that we all love and enjoy. Now, the other reason science is so important and research is so important and understanding all these concepts is so important, even if you're not going to become a researcher, right? Most of the people watching this, you're probably never going to become a researcher. I'm sure you could if you wanted to, but most people probably won't. But we still need to understand research. And this is kind of exhibit A as to why. This man, his name is Edgar Madison Welch, and he started consuming what he thought was truthful information and came to believe that there was an underground child sex trafficking ring, literally underground, under a pizza joint in Washington, D.C. So he went to rescue those children and shot the place up. Luckily, nobody was killed, but he was arrested and sent to prison for this crime because he believed things that just weren't true. He was not a good consumer of science and research-backed information the way we all should be, right? And there's tons and tons of anti-scientific beliefs out there that have absolutely no basis in research and science and fact in the way that scientists use those terms, right? There are anti-science movements all across the world that take some particular conclusion of science or some particular belief in science, some particular fact that science has shown us, and they say, oh, that's not true, or oh, that's wrong, or oh, that's bad, without any actual scientific fact and process and research to back them up, right? So the anti-global warming, people saying the globe's not warming, or if it is, it's due to natural causes and all these things, that has no scientific research to back it up. The anti-vaccine movement, the anti-GMO movement, the anti-evolution, the flat earth conspiracy theories, the moon landing hoaxers, and kind of an oldie but a classic is the people who think that fluoride in the water is a bad thing. These are all anti-scientific beliefs that are completely at odds with all the actual research that we have that's been done and done properly and put through the peer review process and all those kind of research methods that I'm going to be teaching you about in this class. Now, science relies on this research process, and we're going to go all into the research process and how research works and some common forms of research, and but importantly, there are rules, ethical rules, mathematical rules, scientific rules that have been laid down that govern how this process works. What has to happen first, what has to happen second, how these things need to be reported, what needs to be reported, all those things. It's all based on these rules that we really started creating 300-400 years ago, but really became a lot more codified and stringent in, say, the past 100 years, or maybe even the past 50 years, right? But it relies on evidence, right? You can have the greatest idea in the world, but if you can't find solid, scientific, measurable, repeatable evidence for that idea, it's just not scientific, right? Now, one of the big problems with modern science is in reporting, because the actual process, the proper process for reporting on science is through the peer-reviewed journal process, which we'll discuss later on in this course. And that can be a little bit dry. Scientists who write for a particular scientific audience use language and such that is very difficult to understand, which means that the news media has to kind of interpret from scientific ease into language that normal people can understand. And let's just say the job they do most of the time is not that great, right? The modern journalists, I'm sure they're trying their best, but their motives and their understanding of this scientific data and scientific fact and scientific theory usually leave a lot to be desired, and then they change it into something designed to be consumed by the general public, not for understanding purposes, but for attracting readers purposes, right? So, who can we trust? Well, when it comes to reporting science, the only group you can trust with any sort of certainty are peer-reviewed journals. There are some sources on the internet where you can find these. Again, we'll talk about those later in the course. But when it comes to major news media, be very careful about what you read and what you understand. The ability of, whether it's newspapers, television news, websites, their ability to report on scientific aspects of research are not the best. Now, one of the things that people often get confused about, especially as I've personally seen on social media, is the difference between a fact and an opinion. Okay, a fact is defined by the fact that it is measurable. Okay, an opinion is by definition not measurable. So if you try to make a claim about something that is measurable, that is not an opinion, right? So an opinion is something like, oh, I love pineapple on pizza, or I think Taylor Swift is a better musical act than the Rolling Stones. Because those are fundamentally non-measurable. But a fact is, so something like in 1776, the United States declared its independence from Great Britain. That is something we have evidence for. We can measure that, right? The tallest person in the world was 7 foot something. I can't remember the exact measurement, but that is measurable, right? In this case, literally, we could measure that person, right? So, if somebody tries to say, oh, well, I believe this, global warming's not happening. And you say, well, it is. We've measured this. We know global warming is happening. And they just say, well, that's my opinion. That's not how opinions work. That's whether global warming is happening or not is a matter of fact, not a matter of opinion. And if you think it's not happening, that's not your opinion. You're just wrong. right? So if it is measurable, it is a matter of fact, and you can be either right or wrong. If it's fundamentally immeasurable, like whether vanilla ice cream is better than chocolate ice cream, that's not measurable, and thus you can have an opinion on it, and there's no such thing as right and wrong. But those are two very, very different things. Now, here's a really important question that I bet a lot of you probably have never asked yourself. What is a sandwich? We've all got an idea in our head of what a sandwich is, right? We can take one look at a thing sitting on a plate at a lunch table and say, oh yeah, that's a sandwich. Or no, that's not a sandwich, right? But have you ever actually sat down and tried to define the word sandwich? It's a lot more difficult than you might think, right? Now, when I ask this in my in-person classes, I often get something like, oh, it's 2 pieces of bread with some kind of filling. Well, in that case, if I took, say a hoagie roll and just cut a slit in the side and put ham and cheese in the middle of it, that's only 1 piece of bread, because I didn't cut it all the way through and make 2 separate pieces. I just cut a slice in 1 piece of bread. So by your definition that a sandwich requires 2 pieces of bread, that's not a sandwich. And I say, okay, well, it's bread surrounding some kind of meat and cheese. Well, then a peanut butter and jelly sandwich isn't a sandwich, right? So it can be very, very difficult to get a specific definition of even such a simple word, right? There's ingredients, there's the structure of the sandwich, right? It's, there's is a hot dog a sandwich? Is a taco a sandwich? Right? And depending on the very specific language that you use to define what a sandwich is or is not, the answer might be yes and the answer might be no. But importantly, once you've made that definition, you have to stick to it. Because even while the concept of sandwich is something that we all understand and it's easy to identify, and you can take one look at a thing and say whether it's a sandwich or not, actually figuring out how to specifically define that term is a pretty big challenge. So here's a couple of different examples of people who have tried. So this is from Massachusetts, court case. A sandwich includes at least 2 slices of bread, and under this definition, the court finds that the term sandwich is not commonly understood to include burritos, tacos, and quesadillas. But once again, if it requires at least 2 slices of bread, then you're saying, say, a piece of pita bread with stuffing inside that piece of pita bread is not a sandwich. When I think it is. I think it should be, right? By my conceptual idea of what a sandwich is, I would say that's a sandwich. If I cut a slice in the side of a hoagie roll and put ham and cheese in there, to me that's a sandwich, even though by this definition, it doesn't meet the definition, right? So 2 slices of bread or the top and bottom sections of a sliced bun. All right, so we're opening up the definition a little. Must contain at least 35% cooked meat and no more than 50% bread. But once again, this kind of by definition excludes a peanut butter and jelly sandwich, which contains 0% meat, or even a cheese sandwich, right? Any form of bread with a filling generally assembled cold to include blah, blah, blah. Here's some examples. But notice that any form of bread with a filling generally assembled cold would include things like tortellini. Because, that's bread with a filling. So this definition might be too wide, right? But in general, it kind of has these criteria, right? It's food, contains bread. The bread is baked separately from the ingredients or fillings or whatever. Usually has to have at least 2 separate bread layers, not necessarily 2 separate pieces of bread. But taking these common criteria and turning that into an actual strict definition that includes all the things we want to include, but excludes all the things we want to exclude, is a really, really difficult thing. right? For instance, what qualifies as bread? You know, is it rye and sourdough and wheat bread and white bread and those things? You know, we can give lots of examples, but is a baguette bread? Is a hot dog bun bread? Is pasta bread, right? You could make the argument that a lasagna is just a multi-layered sandwich, right? So this process is important because in science we have to have strict definition of all of our concepts. In this case, the concept is sandwich. And we all have enough of a concept of sandwich in our heads that we can go about our everyday lives and know what a sandwich is. But if we're going to be doing science, if we're going to be doing research, we have to define sandwich very specifically. We have to define crime very specifically. We have to define mental illness very specifically. We have to define all these different terms that we all know what they mean conceptually, but we have to be strict. We have to define it. We have to have some kind of measurable inclusion and exclusion criteria. And that definition is going to be vastly different depending on culture, depending on time period, depending on all these things. So one of the most difficult things for most of my students to do in my research methods class is use language and definitions and specificity to the degree that science really requires. We have to be really precise in our language. We have to be really precise in defining concepts and then sticking to that definition. We can't use these casual conceptual ideas that are kind of vaguely ill-defined, like I know it when I see it kind of things. We have to be precise. We have to be careful. We have to be really, really, really detailed. And that is a huge challenge for most students, and even a lot of researchers have trouble with this. All right. Thank you so much. Welcome to this course. That is the end of our little introduction here. I appreciate you watching.